Imagine you're updating a spreadsheet. If one cell is bad, the whole row and column must be wiped clean. Set matrix zeros is a pattern mastery 100 must-have, featured at Google, Meta, and Amazon to test your space optimization and matrix manipulation skills. Over 35% of candidates use extra space or miss subtle row/col edge cases. Master this and you'll be ready for any advanced in-place update problem. Let's break down set matrix zeros using the basic approach, so you can tackle any in-place grid update question with confidence. Given an MXN matrix, if an element is 0, set its entire row and column to 0, in place. 2D list matrix, of size MXN. The matrix is updated in place. Imagine handling a data table where any bad sensor reading, 0, wipes out all readings in that row and column for analysis. Interviewers might ask, how do you update a matrix based on its own data, without using a lot of extra memory? What's tricky? Naive. Use extra arrays to mark all rows/cols with 0 OM plus N space. Optimal. Reuse the first row and first column of the matrix itself for markers, O1 space. Must handle the special case of first row and column carefully, as they're both data and markers. First, scan the first row and column to check if they need to be zeroed at the end, save 2 flags. For each cell, I, J, if it's 0, mark its row and column by setting matrix I0 equals 0 and matrix 0J equals 0. On a second pass, use the markers to set cells to 0, skip the first row and column for now. Finally, zero out the first row/column if needed, using your flags. Let's clarify. Markers in the first row/col allow you to track zeros without extra space. The first row and column are handled last to avoid overwriting markers early. Edge cases. All zeros, full matrix zeroed. No zeros, matrix stays as is. Only first row/col have zeros. Use 2 flags, first row 0, first col 0. Scan the matrix for zeros, set markers in first row/col. In a second pass, for cells I, J, except first row/col, if matrix I0 equals 0 or matrix 0J equals 0, set matrix IJ equals 0. Zero out the first row/col if needed. 3 passes, 1 for flags/markers, 1 to update cells, 1 to update first row, col if needed. No extra arrays. Now let's solve solution 1, setting entire rows and columns to 0 in a matrix if any cell is 0, using extra sets. We'll see how to first record which rows and columns have zeros, and then update the matrix accordingly. Time complexity is OM times N, where M is the number of rows and N is the number of columns. We traverse the matrix twice, once to record zeros, once to update values. The idea: traverse the matrix once and record rows and columns that contain zeros using sets. Traverse again, and set any cell to 0 if it belongs to a recorded row or column. Think of it like marking rows and columns that need cleaning, then wiping them in a second pass. We define a class solution to contain our method. This function takes a 2D list matrix and updates it in place according to the 0 rules. Compute the number of rows M and columns N in the matrix. Initialize 2 sets to keep track of which rows and columns should be zeroed. Traverse each cell in the matrix. If a cell is 0, add its row index to 0_rows and column index to 0_columns. Traverse the matrix again. If the current row or column is in the sets, set the cell to 0. This updates the matrix in place. And that's how this algorithm works. It first records which rows and columns contain zeros, then updates the matrix by setting all relevant cells to 0. Efficient, simple, and easy to understand. Time complexity, OM times N, 2 passes through the matrix. Space complexity, OM plus N, storing row and column indices in sets. Simple and intuitive solution using extra memory to track zeros. We have a matrix where any 0 sets its entire row and column to 0. Input 111101111. The solution records which rows and columns have 0, then updates them. Output 1010000101. The function works correctly and efficiently. This solution sets entire rows and columns to 0 if a 0 appears in the matrix. We use extra sets to remember which rows and columns need zeroing. It's simple and easy to understand. Time complexity is OM times N, where M is the number of rows and N is the number of columns. We traverse the matrix twice, once to record zeros, and once to update the matrix. Define a class solution and the function set zeros. Get the number of rows m and columns n in the matrix to help loop through every element. Create two empty sets to store the row indices and column indices that contain zeros. Loop through every cell. If a zero is found, add the row index to 0_rows and the column index to 0_columns. Loop through the matrix again. If a cell is in a 0 row or 0 column, set it to 0. This approach uses OM plus n, extra space for the sets. Each cell is visited twice, giving OM times n time. It is easy to understand and implement. We have a 3 times 4 matrix, 0 1 2 0 3 4 5 2 1 3 1 5. Every 0 sets its entire row and column to 0. The solution first records which rows and columns contain zeros, then updates the matrix accordingly. The output is 0 0 0 0 0 4 5 0 0 3 1 0. This confirms the function works correctly, efficiently updating all affected rows and columns. Breakdown recap. Conceptually, whenever a cell is 0, its entire row and column must be set to 0. The challenge is to do this in place without using extra memory beyond a few variables. Assess recap. A naive approach uses additional arrays to track which rows and columns need zeroing, but that costs extra space. The optimal approach cleverly reuses the first row and first column as markers while keeping track of whether they themselves need zeroing. This reduces space complexity to 0 while maintaining clarity and correctness. Structure recap. Here's the plan. Use two flags for the first row and first column to know if they need zeroing. Scan the matrix. For each zero found, mark its row and column in the first row and first column. In a second pass, update the cells based on these markers, excluding the first row and column. Finally, zero out the first row and first column if the flags indicate it's needed. Implement recap. We implemented 3 passes. First to set markers and flags, second to update the inner matrix, and third to handle the first row and column. Running this on LeetCode executes cleanly and efficiently without extra arrays. Check recap. We verified that the solution handles all edge cases, including matrices with all zeros, no zeros, or zeros in the first row/column. Time complexity is OMN, and space complexity is O1. Closing insight. The key takeaway? By cleverly using the matrix itself as markers and handling the first row and column last, you can update the grid in place efficiently and elegantly. This approach generalizes well to many in-place matrix update problems in interviews.